Welcome to the ATC Double Cut. I am Micah Woods, and I have a catch-up episode today. I have a few posts I want to talk about that I've written over the past couple of weeks, and I am just going to do a monologue today after a series of shows in which I had some guests like Mike Richardson, Chris Tritabaugh, Brian Whitlark talking about total organic material testing and the terminology that we use for organic matter or total organic material in the soil. And also Joe Galati and I talked about some of the blog posts that bomb, which is always a fun one for me to talk about as we reflect on things that people are interested on clicking through to read and things that people maybe are less interested in. So in today's episode, I'm going to start off talking about summer, because in the Northern Hemisphere, summer is just about here. And this post that I want to discuss is last summer at 36 locations. And this is an application of the turfgrass growth potential from Pace Turf. And it's a temperature-based growth potential where it's a number on a scale of 0 to 1, or if you multiply that number that's on a scale of 0 to 1 times 100, you now have it on a percentage scale from 0 to 100%. I generally like to use a scale of 0 to 1, but in some cases, I like to use it on a scale of 0 to 100, which is just a matter of expressing it as a percentage or as a number on a scale of 0 to 1. Anyway, I have been interested for a long time in where it is most difficult to grow grass in the summer, because being a greenkeeper in places where it's hot can be quite challenging when the nighttime temperatures are so high, the daytime temperatures are so high, and that goes on and on and on, and you've got cool season grass. So I'm mostly interested in heat stress on cool season grass, because heat stress on warm season grass is not a huge thing for me to be concerned about. It's more drought stress that we would be concerned about, or lack of water for warm season grass when it's really hot. But actually, the hotter it gets in the temperatures that are seen on planet Earth, generally, if you have enough water, the warm season grasses are going to grow better. But that's not the case with cool season grasses. And the growth potential can be calculated for both cool season grass and for warm season grass. And what the growth potential is a number that's close to 1 or 100% when the air temperatures are close to an optimum for growth for that particular type of grass. So it's set at an optimum temperature of 20 degrees Celsius or 68.5 degrees Fahrenheit for cool season grass, and that optimum temperature is set at 31 degrees Celsius or 87.5 degrees Fahrenheit for warm season grass. So as the temperature is close to those optima, I think would be the proper way to say it, as the temperature is close to those, then we have a high growth potential that's close to 1. And as the temperature moves farther and farther away from those optimal temperatures, then the growth potential value goes down. So basically, if the cool season growth potential is very high and the warm season growth potential is very low, then we could expect that cool season grass would be in a temperature growing environment that is much more suitable for cool season grass than for warm season grass. But in the summer, that flips around, and we can get into the situation where you're growing cool season grass, but the temperatures are such that the growth potential is actually higher for warm season grass than it is for cool season grass. And the point where that crossover happens is about 25 degrees Celsius. And 25 degrees Celsius is going to be something like 70, it's somewhere between 75 and 80 degrees Fahrenheit, I guess. Now, we could just express this in temperature values and say, okay, let's count the number of days during which the temperature was higher, the average temperature was higher than 76 degrees Fahrenheit or something like that. But I think it's really simple, and I don't know, there's something appealing about the growth potential to me that makes it simple by just expressing everything on a uniform scale from 0 to 1 and just looking at it that way. So what I did for 36 locations around the world, I calculated what I call the delta GP, or the delta growth potential. And I will put a direct link to this blog post in the show notes so that you can check it out. And I looked up temperature data from the summer of 2022, from last summer. And I included some Southern Hemisphere locations. So for the Southern Hemisphere locations that are included, and those are places like Perth, Melbourne, Sydney, Johannesburg, Christchurch, Durban, Brisbane. Those are a few of the places that were included. Adelaide. I used the summer of 2022 and 2023. So the most recent summer that we were looking at in the Southern Hemisphere, and also the most recent completed summer in the Northern Hemisphere. Those are the temperatures that we're looking at. And so for each day, I took the actual average air temperature and I converted that to a cool season grass growth potential, and I converted that to a warm season grass growth potential. And then I took the cool season grass growth potential and I subtracted the warm season grass growth potential. So this is a very simple way to see what the growth potential equation is saying in terms of it being more suitable temperatures for cool season grass or more suitable temperatures for warm season grass. If the cool season growth potential is higher than the warm season growth potential, and that's going to be when the temperatures are less than about 25 degrees Celsius or less than 76 or 77. I'm just guessing on this Fahrenheit conversion, but I think it's pretty close to that. If the temperatures are below that if the average temperature over the course of the day is less than that, then we can say that the temperatures are more suitable for cool season grass, and the growth potential will be higher for cool season grass than it will be for warm season grass. When the actual air temperature, the average air temperature, is higher than 25 degrees Celsius, then the growth potential for warm season grass will be higher than it is for cool season grass. So that subtraction of C3 GP minus C4 GP will be a negative number. And that difference I call delta GP. And I put C3 GP and subtract the C4 GP. So C3 is cool season grass, C4 is warm season grass. If we add those days together, some of the really hot places like Phoenix, Arizona, Dubai, United Arab Emirates, and Miami, Florida, they have a number of days in the summer that is over 150, 150 days or more, with the warm season growth potential exceeding the cool season growth potential. And those, so the 4 places in this data set that had more than 150 days above those temperatures are Naha in Okinawa, Phoenix, Arizona, Dubai, and Miami. Those places tend not to have cool season grass on the greens. Now, you get a little bit north of Phoenix, a little bit higher elevation up into Scottsdale, the temperatures will be a little bit cooler. And this makes me think that I should look it up for some of the golf course locations that do have bent grass in the desert, and see what the threshold is there. But for Phoenix, for the city of Phoenix proper, it is up around 175 days last summer with the warm season GP exceeding the cool season GP. For Naha, it's almost all warm season grass there. That's over 150 days. Dubai and Miami are both over 225 days. So that kind of shows us the type of temperatures and the type of locations where warm season grass clearly is going to perform better than cool season grass. But then we start getting into places where it's just really, really difficult to grow cool season grass, but cool season grass is the dominant species on greens. And now we start looking at places like Shanghai. There were 100 days. Osaka, 100 days. Athens, Greece, a little over 100 days. Rome, where the Ryder Cup is going to be this year, 100 days. Augusta, Georgia, a little bit over 100 days. Of course, at Augusta National Golf Club, which has bentgrass greens, that golf course is closed during the summer. Dallas, Texas is really high. Dallas is between 125 and 150 days. And I know there are quite a few courses in Dallas that are using creeping bentgrass. So how do you handle that? Maybe really good management, use improved cultivars that have better heat tolerance, better disease resistance, I suppose good air movement, and very careful irrigation. And you can then survive with creeping bentgrass on greens in a place like Dallas. And then there are a lot of places between 50 to 100 days. So anyway, I'm not just going to talk about this. Have a look at the chart. There is a chart that you can look at that shows how different places are. And to me, it is kind of a ranking of which places are going to be relatively more difficult. And this, of course, is ranking the summer of 2022. So you get down to some places where it just doesn't get that hot, like London, Sapporo, Stockholm. They're all on this list, but you can figure that they only had just a couple of days. They just had a couple of days where the temperatures were better for warm season grass than they were for cool season grass. So this kind of data analysis of temperatures has been a hobby of mine, and I've had various ways of looking at to try to understand for myself which places are the most difficult for cool season grass, and also just trying to understand maybe what the thresholds are. Like where is it just crazy to even try cool season grass? And that kind of the inverse goes too. Where is it kind of crazy to even try warm season grass? So that leads to the whole transition zone area. And I talked about that recently with Mike Richardson, if you've listened to that podcast, where he was talking about the transition zone that he's familiar with in Arkansas, and talking about in those type of temperatures, he thinks it's probably better in most cases to be using cool season grass, to choose bent grass for greens, or that would be his choice. And the reason being that you've got to contend with winter also. And when you have to deal with winter and the potential for winter kill on warm season grasses, then you're probably better off dealing with a few days or a couple of months of extremely difficult conditions in summer, but at least you don't have the risk of your grass getting killed in the winter. So it's interesting. Maybe there's no right answer, but these are the type of calculations that I really enjoy making, and the paste turf growth potential can be really useful for simplifying this. And instead of just looking at like what the average temperature is at all of these places, we can just do something simple like the delta GP and kind of get a ranking. So that's a number that I think I'm going to start using more often. And if you are in a very cool place, then it may not be so relevant for you, because almost all of the days are going to be better for cool season grass. Even in the hottest times of summer, it's still going to be better temperatures that are more suitable for cool season grass than it is for warm season grass. So I included a couple places on here that didn't even make the list. I looked up data for last summer for Cape Town in South Africa, and I looked up data for Wellington, New Zealand. Then I was thinking that and Auckland also. I was surprised. Christchurch in New Zealand is on this list. Christchurch had a couple of days where the average temperature was better for warm season grass than it was for cool season grass last summer. But Auckland did not. So I was surprised to find out that Auckland apparently has milder temperatures, and there may be some more extremes in Christchurch. And Wellington, It's a harbor city, and I know it's quite windy there, and perhaps it's influenced by the ocean temperatures. And it was relatively cool there also in Wellington. So in Wellington, there weren't any days last summer that were better for warm season turf in terms of just the growth potential calculation. So there weren't any days above 25 degrees Celsius in the data that I was looking at. And also Cape Town was the same. So I know that you could grow some warm season grasses there, but it wouldn't be ideal if the growth potential is never above if the growth potential is never better for warm season turf than it is for cool season turf. But I'm thinking mainly of greens here because I know when you have larger areas that require mowing and require irrigation, then when you start talking about fairways and rough, then for those areas, you start to see some real efficiencies if you can use warm season grass instead of cool season grass. You get these amazing efficiencies when you can use warm season grass in these areas that are relatively cool because you don't have to mow that often. And warm season grasses are so much more efficient at water use, requiring so much less water, that you can have a much lower irrigation requirement in those kind of temperatures, and you can have a much lower mowing requirement. And on these larger areas, you don't need to have so much recovery from traffic like you would on a concentrated traffic area like a golf course putting green. So the whole grass selection thing is just fascinating, and you can, of course, find lots of information about this on the ATC blog. Where else didn't have any days? Oh, San Francisco. San Francisco was in this database. San Francisco also had 0 days last summer that were better for warm season turf than for cool season turf. So this is a calculation that I've made, and I've written some articles about it for Golf Course Seminar for the column that I write in Japan, where I've made other calculations related to delta GP. So that is that's something that I hope you will check out, especially if you're in a transition zone area or if you're interested in how different places compare. And on the date topic, I'm going to real quick talk about a post that is called Best Time of the Year to Soil Sample. And this was a quick one when I was looking for a post to write, and I went through my list of blog posts to write, and I thought, let me just remind everybody, this is a question that often comes up in seminars. It often comes up in webinars. It often is asked when I am talking about soil testing, and people ask, what's the best time of the year to soil sample? And my answer is, if you can, test in the autumn. And the reason why I like to test in the autumn is because it gives us the entire winter to look at the results and make a fertilizer plan and decide what products to apply and make a plan for what to apply and when to apply them. So I think it is clearly the best time of the year to soil sample. Another reason is if you test in the autumn, you're testing at the end of the growing season. So you're testing at the time of the year when the grass has taken up the nutrients from the soil that it was going to take up. You're testing after you've made all the fertilizer applications for the year. So you're testing and seeing what's happened after the grass has taken everything up. And it tends to be the time of the year when you'll have the lowest nutrient levels in the soil. There are a couple exceptions to this. The main one that I think of is in places that have a Mediterranean type climate where almost all of the precipitation happens in the winter. In that case, you tend to have an accumulation of salt and consequently an accumulation of nutrients that will be measured on a soil test, and those accumulate through the summer and into the autumn. So if you test then, you're getting quite a bit of salt, and those nutrients and that salt will then leach through in the winter with the winter rains. So if you're in a place like California, some of the American desert Southwest, and in the Mediterranean region in Europe, or places with a climate where you tend to get not very much summer rainfall, and a lot of winter rainfall. In those places, the best time to test should be towards the end of the winter rainfall season. And in that case, you're going to try to be testing at the time of the year when the soil nutrients are at their lowest. Because then when you find out how low the nutrients can get in your soil, that's how you can really find what the accurate fertilizer recommendations can be. You hate to be testing at the time of the year when the nutrient levels are artificially inflated. And if you test in a place like Chicago, if you're testing in a place like Chicago in the spring, then you can expect that some of your nutrient levels will be higher in the spring than they were in the autumn, even if you don't apply fertilizer. And the reason for that is because of some of the freeze-thaw cycles will release some nutrients into the soil. And you'll test a little bit higher in the spring than you will in the autumn. And I would rather figure out what the lows are. So I want to test in the autumn if I can. And I also don't like, I realize that most people test in the spring. I know that because I provide soil testing as a service. And most of my clients test after January 1st in the Northern Hemisphere, going through to about April. And it is a huge rush. It's a huge rush because the temperatures are warming up, the grass is starting to grow, and we're trying to get these samples tested at the lab and then get the results back. And everybody's very anxious to see the results and quickly make a decision. And then the grass is already growing. And I just feel that's the wrong time to test if you can avoid it. If you're able to test in October or November or December, it gives then the entire winter to leisurely look at the results and make a good fertilizer plan for the next year. So that is my idea about that. And that is also sort of related to dates or related to summer or seasons. So there were a couple of posts that were about seasons, which was last summer at 36 locations and best time of the year to soil sample. Now, I want to recommend two things, and they are two videos or two podcasts that I really think that will be interesting to the people who listen to the ATC Double Cut. One of these is a podcast from Chris Tritabaugh, and he had Frank Rossi on as a guest. And this is a post that I wrote about with a direct link to that conversation on Chris Tritabaugh's podcast. This post has a title, Successfully Complicating Something That Distracts Us from the Real Challenges We Should Be Addressing on Golf Courses. That was a quote from Frank Rossi in that conversation, and Chris invited Frank on the show to talk about the park grass experiment. The park grass experiment is absolutely fascinating. It is the longest running ecological experiment in the world, and it just so happens that it is an experiment that's conducted on permanent grassland. And the fact that this experiment is conducted on grassland and has been since 1856 means that it is very interesting if you have time to think about this kind of thing and have time to look at some of the photos or some of the videos or some of the information about this experiment. And I have put a link to the conversation with Frank Rossi and Chris Tritabaugh here, and I suggest you listen to this because they started off talking about the park grass experiment and what we can learn from it in the turf grass industry, but then they end up talking about a lot of other things that are really interesting too, like fertilizer and bent grass and dogma and salaries of golf course superintendents, salaries of assistant superintendents, salaries of the crew, budgets, detail work at high-end golf courses, GPS sprayers, how many products you mix in the tank, whether you can use GPS sprayers effectively if you have so many products mixed in the tank. So that is a really good conversation. I suggest that you listen to it. I put links to where you can listen to that in the blog post. And then I put some links about the park grass experiment because Chris and Frank started talking about the park grass experiment, and they referred to the park grass experiment a few times, but their conversation was so wide-ranging it may leave people with some curiosity about what is this experiment that they're so passionate about talking about. That Frank learned about it when he was doing his master's work, and then Frank and I had some conversations about it. He introduced that to me when I was a graduate student. I had a chance to visit there a couple of times, maybe 3 or 4 times when I was a graduate student. And one of those times was with Dr. Rossi right before the 2005 International Turfgrass Research Conference. It's an amazing experiment. And the reason why it's so amazing for me, of course, I like history. I like science history. But just from a turfgrass perspective, what's so amazing is I wouldn't have thought that just putting fertilizer is going to allow weeds to proliferate or stop weeds from proliferating. And it's easy to say that. It's very easy to say that, and it doesn't really have much power. But what surprises me when I stand on the park grass experiment, when I stand on those plots, and it never ceases to amaze me. I've been there almost 10 times, I think. I've been there many times. I often take an extra day when I'm in London and I swing by the park grass experiment because I want to see it at different seasons of the year. And I want to see if particular weeds are flowering or not flowering and what I can find. So what's so powerful for me and what always surprises me when I'm there is at the plot boundaries from one plot to the next, we're talking about a difference of, 1 step. So 1 meter. I can have 1 foot in one plot, which has one type of soil chemical condition that's caused by the fertilizer that's applied there. The fertilizer is applied by drop spreaders. So it has these really sharp edges at the plot boundaries. And it's not broadcast spreaders where you have intermingled products being applied at the boundaries. It's sharp edges. And you'll find 1 set of species growing in one plot, and then you just take 1 step, you move 1 meter, and you get a completely different set of species growing. And it's something that even just talking about it, I think it doesn't seem so impressive just with words, but then you go and see it. And as somebody who's been a greenkeeper, as somebody who works as a turfgrass scientist, and I think for all of you who are listening, who are interested in turfgrass science, it's just an incredibly amazing thing to see when you see with your own eyes that I'm on this plot that, for example, has had only ammonium sulfate, and it looks practically like a lawn. You just think, okay, if we just would irrigate this and mow it frequently, this would look like a nice bentgrass fescue lawn. And you think, okay, wow, that would be pretty good. And then you just take 1 step, and all of a sudden you're in something waist high, and you can barely find any grasses. And the grasses that you do find are the coarsest types that you would never want, but mostly it's a lot of weeds that I can't even identify. Now, fortunately, the park grass experiment is a scientific experiment where they have collected data for over 150 years. A lot of that data is publicly available, so we can look up what species are growing in the different plots. And so I don't worry about memorizing all of the species. But you can find on the plot that hasn't been fertilized for the duration of the experiment would be like what a meadow would be. So that has something like 42 species that are growing on it. But then when you put nitrogen fertilizer at a moderate rate, what would be similar to a turfgrass maintenance rate, when you put ammonium sulfate at a rate like that, it acidifies the soil, and both the nitrogen and the acidification will reduce the number of species to where we'll get down to only like 3 or 4 or 5 species and they'll almost all be grasses. And so it's interesting to see that. And it's just so powerful to see at the plot boundaries. In the center of the plots, it's interesting. But what's surprising to me is at the plot boundaries, just how sharp that edge is. And that edge happens not because it's different soil types. Well, it's all the same soil on the same meadow, but those differences are because of fertilizers, and those fertilizers have caused slight changes in the soil chemical properties, and those slight changes in the soil chemical properties leads to completely different species composition. It's incredible. And so I like to learn about that all that I can. And then if you're interested in the history of agricultural science, the Rothamsted Research, the Research Institute there is just fascinating. There have been so many contributions to agricultural science. Many of you, I know a lot of golf course superintendents in the United States will know what an ANOVA is, for analysis of variance, or will have seen those tables that are often presented in seminars about whether something's statistically significant or not, looking at different wetting agents, for example, and seeing if there was a statistically significant difference in localized dry spot, or looking at different fairy ring treatments, for example, and seeing if there was a statistically significant difference in fairy ring symptoms or not, based on different fungicide treatments being applied, or whether the fungicide was watered in or not, or applied with a surfactant or not, right? You'll see those tables. That's what is often presented in seminars that turfgrass managers attend, at least in the United States. You'll see a lot of that. Now that's based on analysis of variance, or ANOVA, and it's based on the some of those date by date comparisons are LSD, least significant difference. That was all developed by R.A. Fisher, Ronald Fisher, and he was employed as a statistician at Rothamsted Research in, I believe, the 1920s and 1930s. And there he invented ANOVA. And he developed many of the statistical procedures that are still used today. I think even randomized complete block designs, which are so common in turfgrass science research. I think he also invented that. So he was hired to look at some of these long-term experiments. What's amazing is even in the 1920s and 1930s, these were already long-term experiments, because some of the other experiments there, the Hoos barley field and the Broadbach wheat experiment, those were started in the 1840s. The parkgrass experiment didn't start until 1856. There were other experiments that were already a decade old at Rothamsted when the parkgrass experiment started. So by the 1920s, these experiments had many years of data, and of course the weather is different every year. There are differences in weather. So one of the things that Fisher was trying to figure out was, how can we account for the treatment effects considering that the weather was different every year? And through that, he developed a lot of statistical procedures, some statistical analysis procedures, and also some experimental design procedures that are still used today. So I just think it's fascinating to be out there, to walk from the train station in Harpenden over to Rothamsted Research, to see some of the old buildings, to walk past the pub, and to walk out to the parkgrass experiment, and to see these experiments that are still ongoing, but that have had such a huge impact on modern science. So that is fascinating. And what I'm encouraging you to do, if you haven't already, please listen to Chris Tritabaugh and Frank Rossi have a talk about this, because they talk about the parkgrass experiment. They talk about some of the stuff that's so obvious from the parkgrass experiment. And then they start saying, okay, why does everybody not know this? Why does everybody not care about this? And why are we applying products? Why do we apply fertilizer products that the grass doesn't need, that the soil won't hold, and that information from long-term experiments such as the Rothamsted park grass experiment would suggest that some of the treatments that we make, like trying to balance soils, adding lime and adding potassium, adding magnesium, adding various things that are not necessary when the soil already has enough to support good grass growth, when we're trying to do these things, it may actually be detrimental. In the case of potassium, for example, if you're in a cold place and you're adding potassium, you are likely increasing the amount of snow mold pressure. But of course, if the potassium is too low, you could have problems also. That's why we can do things like soil testing to figure that out. And so sometimes you need to add more, but we can learn a lot from the park grass experiment. And I think it's pretty much the most interesting experiment to look at for both history of science purposes and just some of the ecological stuff that is interesting to look at, and it's sort of related to turfgrass science. And then I'm going to recommend one more, and that is about a interesting thing about OM246. I was just in Japan, and I gave a seminar at Hibari Golf, which is in Takaratsuka, in Hyogo Prefecture, which has tons of golf courses. It's right near Osaka. It's where the famous Hirono Golf Club is. Many of you will have heard of Hirono, which is one of the top 25 courses in the world and always ranked as the top golf course in Japan. And it's got lots of other fine golf courses in Hyogo. I was at the beautiful Hibari Golf, which is on a hill looking down over the Atami Airport, which is used to be the main airport for Osaka. Now it's the main domestic airport, and it's where you'd want to fly into if you could, because it is so conveniently located right next to downtown. And so the golf course and where we were holding the seminar looks down this hill across over the Atami Airport, where we could see these planes taking off, and then over to downtown Osaka. It was really a beautiful place to have a seminar. And the seminar was about OM246, or total organic material testing. I gave that seminar speaking in English, and Mr. Ueno Yukio, who often translates for me in Japan, translated what I said into Japanese. And he translated the slides also, so we presented slides that were all in Japanese. But a lot of the slides were just showing pictures. And a lot of the pictures were about something that I think is absolutely essential to understand about soil organic matter or total organic material testing, which is that they are two different things, and the laboratory procedures that are done cause these results to be quite different. And I wanted to show some pictures and a video that would make this very clear. And I think I did at the seminar, and I think everybody understands what the differences are. And I recorded a screencast of that now. So I've recorded a screencast where I'm speaking in English over those slides that are in Japanese, but a lot of it is talking about the pictures. So it's don't be scared to look at Japanese slides, because my voice is in English, and I'm explaining the key difference, the crucial difference, why you'll see total organic material measurements that are 5 or 6 or 7 or 8 times higher than soil organic matter measurements. And I think it's important to understand this, because if we are going to use soil test values, some soil test measurement of organic material or organic matter, if we're going to use those numbers to adjust the amount of sand top dressing that we apply, or if we're going to use those numbers to tell us where in the soil we should put the sand, or what type of sand we should put, or whether we should be removing cores or not be removing cores. A lot of questions that are highly related to plant performance, playability, disruption of surfaces, achieving really, really high quality surfaces, these are related to the decisions that we make based on some of these test results. And I'm not saying don't test for soil organic matter. I use soil organic matter test results for all kinds of things, and there's nothing wrong with it, and I highly recommend it, and I don't want any changes with soil organic matter testing. But I'm saying add on OM246. Do some sampling for OM246 also, which is total organic material. Because when, I assume everybody knows this because I've been talking about it a lot, but maybe you haven't seen pictures that show what happens at the lab, or maybe you haven't seen a video that shows some of the machines or the tools that are used at the lab that make the difference clear. So I think this presentation makes it pretty clear. And what you'll see is soil organic matter tests are done on soil samples that have had all the thatch. Anything that's like thatch or mat is removed. Any roots, all of that stuff, it gets removed. And then just the soil that remains after you remove all of the organic material, that's what soil organic matter is. Okay? So your thatch is taken off the sample, your mat is taken off the sample, your roots, any living and dead, undecayed plant material is taken away. What's left is soil, and you measure the organic matter on that. That is soil organic matter, which is an important number. But if you are trying to look at what's the effect of the sand top dressing, let's say that you top dressed last year 20% more than you did this year. Wouldn't it be nice to see how that affected the total organic material in the soil? Well, if you do OM246 testing, you can try to answer that question. You can try to figure out what was the effect of adding 20% more sand. The soil organic matter test discards a lot of your organic material, and you can't really figure that out. So I have just recorded this screencast. I do recommend that you watch it if you can. You can watch that at a high rate of speed. And I hope that I speak clearly enough that it's understandable at a high rate of speed, and you could very efficiently get through a lot of material where I'm just trying to make it so clear what the difference is between total organic material testing and soil organic matter testing. So that is the four blog posts that I wanted to mention. So that kind of catches us up here on the ATC Double Cut show. I've talked about all about OM246. I'll put links to each of these posts, or just go to my website, asianturfgrass.com, to see them. But they're the four recent ones, all about OM246. The one with Chris Tritabaugh and Frank Rossi about complicating things. And in this case, I think Frank was talking about fertilizer, about how somehow the industry has successfully complicated fertilizer, and it distracts us from the real challenges we should be addressing. And then last summer at 36 locations, where I think it's absolutely fascinating to look at the difference in growth potential. And then the best time of the year to soil sample, which is kind of an opinion one from me. And I would encourage people, if you can, test in the autumn. I think that's a nice time to test. So that is the information that I wanted to share with you today in this episode. And I will be blogging about some more cool stuff. I've been remarkably busy. I often am, and I repeat that refrain occasionally, but I've been quite busy. So I just take notes in my notebook. I take notes on my computer and say, okay, I want to cover these topics. But as we come into the winter in the southern hemisphere, we come into the summer in the northern hemisphere, that's always an interesting time to consider some of the extreme challenges that we face in turfgrass management. So it also sparks ideas in my mind of things that I would like to share. or things that I would like to research and learn about myself and then share with you. So thanks for listening. Thanks for watching. I hope you will check these out. Be sure to sign up to the ATC newsletter. I sent out one of those a couple weeks ago, and that went out to over 1,000 people. If you didn't get it, check your spam. Check your spam folder, or just make sure that you're signed up, because getting the ATC newsletter, I just put the highlights in there. So the highlights of the information that people have found the most useful over the most recent few months. So anyway, that is all I have for today. I will sign off now from Nonthaburi, Thailand. I am Michael Woods. Bye-bye.